All right, guys. Chapter 1. Chapter 1 homework. All of Chapter 1 homework is due at the end of the day Friday because we're not having a Chapter 1 test. So, if you have any of Chapter 1's assignments out, they need to be turned in by the end of the day Friday. Otherwise, they will be zero. I will get the AMI work graded pretty quickly. It's not going to take me long to grade it, but I will say that I think at least last hour, most of y'all have got question 3 right on the AMI. Because you do realize question number 3 on the AMI was not asking you to solve that system, right? Because it was asking for the augmented matrix. So you wrote it as a matrix. So you had 3 equations. Most everybody in here wrote it as a matrix. I had some from last hour and the hour before actually solving it. Didn't ask to solve. You know. So. The only one you had to solve for was 4, right? Yeah, the only one you had to actually solve for was number 4, and I gave you a whole page for it. There's a reason that number 3 had so little space. You didn't need the space because that's all you needed.
Calculator it was.
Yep.
I hate that.
Yeah.
Literally.
Now, chapter 2 is quadratics. Everything we're covering in chapter 2 and actually chapter 3 is going to revolve around quadratics. Chapter 2 is going to be mainly kind of the properties of quadratics and stuff with quadratics. Chapter 3 is going to be more about solving. So when we talk about this here, quadratics, first thing we're going to talk about with 2.1 is transformations, moving it up, down, left, right, stretch, shrink, and reflections. And we have and we can also think about it as a parentheses bx minus h, close parentheses squared plus k. Now, we'll look at 2 of these here first, and then we'll look at a and b second. The h, if there's a value for h, it's telling us that it's moving the graph to the left or to the right. K is our up and down. H and K. H is left or right, and if we look at the graph, especially mainly the equation, it's the opposite of what we think. Because if it's x plus 3, it's actually moving to the left 3. If it's x minus 3, it's moving to the right 3. Opposite of what we think. Up and down is nice, because if it's plus 7, it's moving it up 7. If it's minus 9, it's moving it down 9. Up and down is exactly what we think. And if we look at this first one here, it's on the bottom part of that first page. Horizontal, left and right. It's just telling us what we have. Vertical, up, down is moving it up or down. Also, I will have everything, well, actually everything is already written on the whiteboard. So if we look at this first one here, given f of x, describe the transformation of g of x. G of x has two transformations. We have the x plus 4 inside the parentheses and the minus 1 outside. Let's look at the plus 4 inside. Since we're adding 4 inside, it means it's moving it to the left or to the right, a movement of 4. Now the question is it left or right? It is to the left, because again, left, right's opposite of what we think. So plus 4 is actually left 4. So it'd be left 4. Minus 1 would be down 1. Because up and down is exactly what it looks like. So since it's minus 1, it is down 1. Down 1, yes. You're good? No. Because for some reason my brain told me I'd written 1. Either that or I wrote the 1 as part of the box. Okay. Yeah. So, questions on this here. So I'm not going to make you graph on the homework. But really, again, we said we took the graph and they gave us the parent function, yes, and moved it left 4, down 1, yes? Now, one of the points on this is the parent function is 0, 0, yes? So the new graph, we would move it left 4 and down 1. So we would go left 4, down 1. That'd be the new point. At 1, 1, we would go left 4, down 1. But again, we're not looking at the exact graph. It's giving us a picture of what it does. Because we're moving the whole thing left 4, down 1. Because this whole graph of the parent function went 4 units to the left and down 1. So we get an idea, a picture of it, yes? And if we talked about its solution, those 2 points where it crossed the x-axis would be the solutions to this here, where this would be 0. No. And the reason I say we're not going to graph, or don't need to as well, x plus 4 squared minus 1, y equals. It did it for us. So there's not a whole lot of reason to graph, but as long as we can understand what the graph is telling us, that's fine. We don't need the necessary mechanics for how to actually graph it. Let's look at the next one. This one here. G of x equals parentheses x minus 3, close parentheses squared. We do indeed only have one transformation. We're moving it 3 units to the right. Because left and right, it's opposite of what we think. Since it's minus 3 inside the parentheses, it's going right 3. If it had been plus 3, it would have been going to the left 3. Questions on this here? How many transformations do we have on the next one? 2. We have the x minus 2 inside and the minus 2 outside. So inside our minus 2 would be right 2. Minus 2 outside, down 2. So that means this here, we didn't do it on the last one, but we would take every point that's on this graph and move it right 2 and then down 2. So 0, 0 would go over 2, down 2. 1, 1 would go over 2, down 2. This point here would go over 2, down 2, and we get some graph that looks like this here. Not exact graph, but it gives us a good idea. Because honestly, the 2 sides of it are a little more skewed than they should be. Questions on this here? We ready for the next one? G of x equals x plus 5 squared plus 1. So the plus 5 inside is telling us we're moving to the left or right 5. It would be left 5, because our plus 5 inside, left, right, opposite of what we think. Since it's plus 5, it's moving to the left 5. Plus 1 would be up 1. So this is moving left 5 and up 1. There's a good reason. It's most likely air, if it has air pockets. Yep. Let's look at this next one here. X minus 1 squared plus 2. The x minus 1 inside the parentheses is telling us we're moving left or right 1. It would be right since it's minus And the plus 2 on the outside would be up 2. All right, 1 up 2. That's it. Questions on this here? Do we feel good with this here? All right. Next thing we have is reflection across the x and y axis. If there's a negative in place of A, or where A is, if it has a negative sign, it means it's a reflection across the x. If the negative is in front of our B, or is our B value, it's across the y. So if A is negative, it's a reflection across the. If we have that negative being multiplied in front of the parentheses or in front of that x outside of parentheses, it's a reflection across the x. If that negative is being multiplied by the x inside the parentheses, it's a reflection across the y-axis. Now the next one we have with this is vertical stretch or shrink. If the number being multiplied outside the parentheses in front of that x, if that number is greater than 1, it's a stretch. If it's between 0 and 1, it's a shrink. We've covered that. We've done that. And that was fine. Horizontal stretch. Horizontal stretch or shrink, when we have that number being multiplied in front of the inside the parentheses in front of that x, before we talk about it being stretch or shrink, we have to flip it. We have to flip it. Whatever that value is, flip it. And if the flip is greater than 1, it's a stretch. If the flip is between 0 and 1, it's a shrink. So with that horizontal, we flip it, then decide what it is. And again, once we see it, it's going to make more sense than us just talking about it in words. So I'll give you all a second for those who are writing to write that down. Yeah. So right there. Yeah. The only reason I know is I really like these pens, and I've had some that have had those. And that really frustrates me when it gets that way. Yep. Yes. Okay. Let's look at these here, because again, I think once we see an example of it, it's going to make more sense than just words on a page. So, here we have negative 1/2 x squared. We have two transformations. The negative 1/2 looks like it should be a single transformation, but it's actually two. We have the negative and we have the 1/2. Are the negative or 1/2 is either or both of these inside parentheses? Are they inside parentheses? Are there parentheses? Well, no, there's no parentheses written, so it's understood that they are outside. And what that tells us is that it's not horizontal stretch or shrink, and it's not a reflection across the y. Both of those are inside. These are outside. Since this negative is outside parentheses, we're talking about a reflection across the x-axis. The negative is specifically a reflection across the x. That's all the negative is telling us. That negative and the 1/2 are two separate transformations. Because the 1/2, since it is outside parentheses, is talking about a vertical stretch or shrink of 1/2. And since the 1/2 is between 0 and 1, it would be a shrink. And that's it. The negative would be our reflection, because we're multiplying by that negative. It's a reflection across the x or y. X if it's outside parentheses, y if it's inside. The 1/2, since it's outside parentheses and it's being multiplied by that x or the parentheses, it's a vertical stretch or shrink. 1/2 between 0 and 1 is a shrink. If it's greater than 1 is a stretch. That's it. Questions on this here? Let's look at the next one. We have two transformations here, yes? One of them's a little bit nicer to determine than the other. What's the +1, yes? What does the +1 tell us? Up 1. Let's list it first. Up 1. That's nice. Now the other one, we have that 2 being multiplied inside the parentheses, yes? That's telling us it's a horizontal stretch or shrink. That's what we know so far. Horizontal. Now before we actually determine if it's a stretch or shrink, we have to take that 2 and flip it. We have to take that 2 and flip it. So if we flip it, it goes from 2 to 1/2. We flip it. Because horizontal stretch or shrink, because that's where that is. That's that horizontal stretch or shrink. We have to take that amount and flip it. Before we even look at stretch or shrink, that is the first thing I say or suggest that you do is take that amount and flip it. Okay? It's a stretch if it's greater than 1. It's a shrink if it's between 0 and 1. So this, between 0 and 1, so it would be a horizontal shrink of 1/2. And that's it. And we have to remember with horizontal stretch and shrink to flip that value. Because it's very tempting to look at the 2x, that 2 inside the parentheses, and say it's a horizontal stretch of 2. We have to flip it. Because vertical stretch or shrink makes sense. Because if we look at the graph, this parent function, vertical shrink means it's increasing faster along the y. Horizontal shrink means that it's increasing slower across the x. Which means we're taking these sides and they're coming in, that's shrinking left and right. It's not increasing as fast. If we stretched it horizontally, it means we're taking those and pulling them out. It's increasing faster along the x. Shrink is slower along the x. Stretch is faster. So if we look at the graph of this here, because it's one thing for us to write it, it's another, if we can see it, x squared, we get this here. Now, parentheses 2x squared, we can see that it did shrink along the x. It got skinnier, which means if it's fractional, it's going to get wider. That's why we have that flip that takes place. Questions on this here? -3x squared. Do we have parentheses? No, so there's no horizontal stretch or shrink reflection across the y-axis. But we do have that negative. It's telling us we have a reflection across the x-axis. Because that's all that negative is telling us. When we multiply that negative in front of our parentheses or x, it's a reflection. Since it's outside the parentheses, it's across the x. Inside would be across the y. The 3 would be talking about our vertical stretch or shrink. And since the 3 is definitely bigger than 1, it'd be a vertical stretch of 3. And that's it. Questions on this here? Yeah. Now, if you notice, especially when we applied them, it only talked about linear and absolute value. We didn't even talk about quadratics because they knew we were coming over and doing this here. How many transformations do we have here? 2. We have that 1/4 being multiplied by x inside the parentheses and the -2. Why don't we deal with the -2 first? Down 2. Now the 1/4 being multiplied inside the parentheses is going to be our horizontal stretch or shrink. It's going to be one of the two. But before we decide that, let's take that value and flip it. So it's going to go from 1/4 to 4. Is our 4 greater than 1 or between 0 and 1? Greater than 1, so it's a horizontal stretch of 4. So that means that 1/4 should make this graph open wider. And it did indeed. Because when we stretch it horizontally, it is going to because we're saying that it's for every 4. It's a factor of 4. So the bigger that number is, the wider it's going to stretch out. Let's look at the next one. How many transformations do we have here? 1. And 1/3 being multiplied by our x would again be horizontal stretch or shrink. It's going to be a stretch because when we flip that 1/3, we get 3. And 3 is indeed greater than 1. Could be a horizontal stretch of 3. Questions on this here? Be ready for the next one. How many do we have? 2. Do we want to work with the 3 or the -1 first? Because the -3 would be left or right, and it would be right one. 3 being multiplied on the outside would be what? It'd be one of our vertical stretch or shrink. Because our reflections across the x and y axis is going to be multiplying by a negative. Since the 3 being multiplied on the outside is positive, there is no reflection across the x. The x inside the parentheses is positive, so there is no reflection across the y. So there's no reflections there. But the 3 is in place of our a. A is vertical stretch or shrink. If the a value is greater than 1, it's a stretch. If it's between 0 and 1, it's a shrink. So this is a vertical stretch of 3. And that's it. Pretty much. We ready for the next one? We have 3. Because our first transformation we have here is the negative plus 3 plus 2. So let's do the plus 2. So we'll move it up 2. The plus 3 inside would be to the left 3. So the up 2 we feel good with. That's what we started with. The plus 3 is moving it left 3. Now since the negative is outside the parentheses, it'll be across the x-axis. Now if the negative was in front of the x inside the parentheses, it'd be across the y. Outside parentheses, that negative being multiplied is across the x. Inside the parentheses multiplied by the x is across the y. Questions on this here? So those last 3 we will do tomorrow.
Oh, those last three.
Yeah.
So which ones are that? 27.
All of this is what we did. Yeah, so 3 through 11 odd, 17 through 21 odd, 27 through 29 is everything we did today. 3 through 11 odd, so 3, 5, 7, 9, 11, 17, 19, 21. Because if odd or even follows the numbers, it's odd or even. If it doesn't, because it's 3 through 7 odd, so you're only doing 3 through 7 odd. 17 through 21 odd, you're doing the odd one of those. 27 through 29, you're doing all of them. But you have the rest of the time to work